Okay, sorry for the interruption. Mirsini wanted to go say hello. And in the time of COVID, you can't do that. So I'm back on my stream and I'm gonna keep taking steps. And each time I take a step, I'll reach down and I'll grab a piece of sediment on the bottom of the stream. This time it's really small and I'll even measure that and then record it and take another step. Reach down, grab this, find its intermediate axis, take a measurement, moving on. You might want to bring a friend to help you, like I have 2 helpers today, and they'll help you record what your 100 measurements. And if not, you can do it by yourself. It's just going to take a little time, which if you're anything like me, you probably have an abundance of. And if you're wondering the whole point of this, I'll give you a worksheet, but you're gonna relate the sediment size, we call it the class size, to stream velocity. And if you look at your stream system as a vehicle for sediment transport, its competency, its ability to transport material is written all over its bank, so and the bottom of a stream. So you can see here in this riffle, there's a big rock that was transported with the power of the stream to get here. So at some point, this stream had enough energy to push this size rock down. Today, it's not flowing nearly fast enough at a velocity to move a piece of sediment like that. Versus, if you see, here's some sediment, it could potentially move that. And through your grain size analysis, you can start to see sort of the annual potential velocity that the stream produces and can move rocks with. I'm going to take you down here to this confluence where my small sawmill creek here in southern Ontario runs into a bigger branch. And you can see velocity is pretty high. There's big class that are here in the riffle. And then as we bend around this riffle, you can see here is your thalweg, here is the place of highest velocity. And you can even see the stream cutting into what would have been a cut bank right there, but you can see they've put in boxes of rocks. The fancy term is gabion, and they've protected the bank with armoring. But what happens is you can see the velocity is really high through this part of the channel, but over here the velocity drops tremendously. And yeah, you can see it as the water's flowing, but imagine we're in the Georges Creek and it's October and the whole thing is totally dry, but you could still see this relic of the grain sizes that are going to tell you, your annual velocity flow regime. So again, here is like high velocity. You can see all this is pushed up and they're big clasts, they're big rocks. And then as it bends around the corner, you can see the velocity drop and it's reflected in the grain sizes. So much smaller grain sizes here where the velocity drops down. All the way into sediment, like fine silts and clays and that type of sediment like you see here. I also realize some of you have selected larger river channels that again, you're not going to be able to cross. But you're also going to see at that point, rivers are usually pretty lazy. The slope has dropped tremendously and the only thing they have the competency to carry is silt and clay. And you might spend your outing collecting and measuring stones, collecting and measuring or trying to measure sand or silt or really small particles. And if that's the case, you just kind of have to go with it and record that. So the second part of what I'd like you to match is you've done a watershed assessment for your study reach, and I've done one on this section, and it's a watershed that's deeply disturbed, even though this looks like a fairly nice wooded area. Off in the distance you can see a big fancy house, and then over there behind Rachel is another big fancy house, and the area is heavily suburbanized, which definitely affects runoff. And I would expect this is a pretty flashy system, one that floods quite often and one that has a high competence and can move a lot of boulders really quickly but isn't subject to perennial flow. And that's pretty much what I'm seeing. I can also see that this flashy system, basically they've increased impervious surface, which increases the amount of runoff, which increases stream velocity. And we call that, you know, after a storm event, a flashy system. And flashy systems usually deeply incised a stream. And this one isn't deeply incised, but it has the potential to. And that's why they've come in and put in this gabion, this stream protection barrier that you can see here. And they've done it the whole way down. And this is just a little tiny stream, and its slope is very limited. This is nothing like we see in Frostburg, where we have dramatic slopes. This is southern Ontario. There's a big escarpment behind me, but everything's just kind of slowly meandering to the Great Lake, or the Lake Ontario. Okay, I will catch back up with you in my makeshift office and explain a little bit more. So again, you're going to take a ruler, a helper if you can, definitely a piece of paper, some boots if you have them, or if it's a beautiful day in the next week, you could even do it barefoot, use your own judgment. And you're going to take a step, and with each step you reach down and you pick up the clasp that's immediately behind your foot. And you might want to notice cool things like bugs on the bottom. And you take the measurement and you move on. Take another step, reach down, pull up a cobble, find the intermediate axis, and take a measurement. And you're going to zigzag across the stream. So I will show you that. You're going to keep going. I'm reaching down, I'm measuring, blah, 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 measuring, blah, 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 measuring, blah, 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 measuring. And then I get up on the bank and I'll turn around and I'll come back and I'll just keep zigzagging across until I have my 100 measurements. And yeah, and that's going to tell you the velocity and really the flow history of this small channel, or whatever channel you've decided. And I'll leave it at that.